Hello everyone and welcome to Instant Biology by Dr. Neelab. The topic that we are going to deal with today is Beer Lambert Law. So in the previous lecture also I had said that we would be dealing with some of the numericals that are often asked on Beer Lambert Law. We would be dealing with three or four of such kinds of numericals. These are the different varieties of numericals that have already been asked in the previous year examinations in different, of course, in GATE, GATB and CSIR net examinations. So before getting into the details, let me just brush up the formulas that are used or that would be used in the upcoming this questions. So let us start. I told you in the previous class that absorbance, or it is also written as A, is equals to log I naught by I, and over here we already discussed that I naught is equals to the intensity of the incident light. So I naught is equals to intensity of incident light, intensity of incident light, intensity of incident light. I is equals to intensity of transmitted light, transmitted light. Epsilon is equals to extinction coefficient, extinction coefficient, or it is also called as absorption coefficient. So this, and C is equals to concentration, and finally L is equals to path length. Always remember that path length would be or should be given in centimeters. Okay, so this is one of the formulas that would be used. This is the first formula that should be used. Next is the concept of transmittance. I've already explained you what transmittance is in the theoretical video that I posted last. So transmittance is equals to, it is just I by I naught. Okay, so absorbance was log I naught by I. Absorbance was log I naught by I, and it can also be written as epsilon into C into L. So these are the parameters that I have mentioned over here, epsilon, C and L, and I naught and I are the parameters that are in this equation. So it can be given as log I naught by I is equals to epsilon into C into L, and transmittance is just the reverse, and the log thing is not there. Just transmittance is equals to I by I naught, no log is present. So T is equals to I by I naught. This is done. Sometimes percentage transmittance is also asked or given. So percentage transmittance is equals to, it is just I by I naught into 100. So this is the percentage transmittance. This you should remember. And finally let us just sum up. So absorbance, I said that it is log, if you remember over here I just wrote down log I naught by I was absorbance, log I naught by I was the absorbance. And if I write absorbance in terms of transmittance, I can also write it like log 10 1 by T, because transmittance was just the opposite of absorbance and log term was not there, so I can write it in this way. Similarly, if you know the logarithm properties, then you would say that since this transmittance is in denominator, I can write it down as uh, minus log 10t. We have put minus sign over here, and this transmittance was in denominator, I have put it in numerator. Similarly, I can also write it down in percentage form, percentage of transmittance divided by 100, since this would be percentage transmittance, and if you divide by 100 it will be the same thing, percentage would cancel out. Similarly, if I write it down in this way, minus uh, log 10 percentage of t. So what I'm doing is minus log 10 percentage of t, and since this 100 is in denominator, if I bring it up, so it will be plus log 10 100, this would be the case. And if I solve this, log 10 100 would be equal to 2, so it can be rewritten as 2 minus log 2 minus log 10 percentage t. So these are some of the formulas that would be used in the upcoming questions. So I've noted down some questions from the Pathfinder book. So the first question is, a solution present in a 1 centimeter cuvette transmits 40% of incident light. Okay, calculate the concentration of the solution given that epsilon is equals to 600 mole inverse centimeter inverse. So let us just write down what has been given to us. So in these questions, first of all, you should be clear what has been given to us and what is being asked. So if you look carefully, then you would see that length has been given to us and it is 1 centimeter. So the cuvette length has been given to us. Okay. So this is the length that has been given to us, 1 centimeter. Okay. So transmittance is 40%. Let us write down that transmittance that means this is suppose the incident light and this is the light that is coming out. So this is I. Okay. So I has been given to you, the light that is being transmitted, it is being given to you as 40% light is getting transmitted. Transmittance is equals to 40%, or you can rewrite it as 40 upon 100 or 0.40. So this is the transmittance, right? This is the transmittance. Again, the next thing that has been given to you is epsilon. Epsilon is the molar absorptivity coefficient and it has been given to you as 6000 mole inverse centimeter inverse. And they are asking you the concentration. Concentration is unknown. So if you remember, we just wrote down the formula in which we could convert this transmittance into absorbance, or absorbance and transmittance were interrelated. Okay, so if you remember, I had just said absorbance is equals to negative log of transmittance. So this is the formula that we had just written down. Absorbance is equals to negative log of transmittance. So if we know transmittance, then just use the negative log of that and you would be getting the absorbance. So we know the transmittance, right? So I can rewrite it. This means negative log of transmittance was 0.40, isn't it? So 0.40 would be equal to absorbance. So if we calculate, if we take the negative log of 0.40, you would be getting 0.39 something. Let us, for our convenience, just write down 0.39, or you can also write 0.40, but let us keep it this way. Okay, so we have got the absorbance. Now you already know absorbance. Let me just change the color and write down the formula. So you already know the other formula for absorbance. Absorbance is equals to epsilon into C into L. So this was the second formula that we had already talked about. This one was first, second. Okay, so now we already know absorbance 0.39 is equals to epsilon. What is epsilon? You already know, it has been given. So epsilon is equals to 6000. 6000 into concentration is not known. into length is known, that is 1 centimeter. So this is very simple mathematics calculation. So in order to calculate concentration, you can 0.39 into 6000, 0.39, oh sorry, 0.39 divided by 6000 into 1. So if you calculate this, you would be provided calculators, or you can do it with the calculator in the examination also. So you would be getting the value somewhere around 6.63 into 10 to the power minus 3 molar. Now look at the, I want you to have a special eye for the units. Why am I saying that? Because you need to provide the units at the end, right? Especially in the, if this is a numerical type question, you would have to write down the end unit. So you can easily understand this, because the molar extinction coefficient has a unit of mole inverse and centimeter inverse, and you already had centimeter in your formula because the length was in centimeter. So concentration definitely would be written in molars. So always remember to write down the units and correct units. So this was the first question that we have done. I'm sorry. Uh, I believe uh, this should be going up, and 6.63 into 10 to the power minus 5 molar should be the answer, right? So sorry for the miscalculation. Right. Okay, so this is the first question. How the first question can be done. I have a few more of them. Let us move on to the second one. So this is the second question. A monochromatic radiation is incident on a solution of 0.06 molar concentration of an absorbing substance. The intensity of the radiation is reduced to 1/4 of the initial value after passing through 8 centimeter length of the solution. Calculate the molar extinction coefficient of the substance. So I would like you to stop the video and try and do this question on your own, because I have already given you the formulas that are present over here. So only these formulas would be used in this question. So for those who are not able to do this, let me just progress with this question. So over here, if you look closely, something has been mentioned. Just a moment. This is a very important information that they have mentioned, is the intensity of the radiation is reduced to 1/4 of the initial value. What does this mean? So this simply means, let us just start solving the question. Now suppose this is the cuvette, okay? Now suppose this is the cuvette. I'm passing a radiation over here. This is I naught, and from this side I is emerging out. What I'm trying to say is that the intensity that is emerging out has reduced to 1/4 of the initial value. That means I has become 1 by 4 I naught. Okay, so I is equals to 1 by 4 I naught. So what can I write? This is what they are saying, that the intensity that is coming out, I is equals to 1 by 4 I naught. That means that the intensity that is coming out is 1 by 4 of the initial intensity. So this is what we can reach out to. Now if I try and bring I to this corner, that means if I try and bring I naught divided by I, if I bring I over here, I naught divided by I would be equal to 4, isn't it? This is very simple. Okay, this is very simple, and you already know from the previous formulas that absorbance is equals to, absorbance or A is equals to log I naught by I. So this we have talked about. Now utilizing this formula, what I can do is I can somehow calculate sorry, I can somehow calculate the absorbance, isn't it? So let me just use this formula and calculate the absorbance. So this particular thing I naught by I has been given to you as 4, isn't it? So this is equals to log of 4. So absorbance is equals to log of 4. So this is from the first formula. Now we also have a second formula in which we say that absorbance is equals to epsilon into C into L. This is the second formula. Now since we have calculated absorbance from the first equation, what we can do is we can use this log 4 value over here in the absorbance, and we can equate it to epsilon C into L. And you already know all the other things. You just need to calculate molar extinction coefficient, and everything else has been given to you, isn't it? So if you look closely, then you have been given 8 centimeter as the length, path length. Okay, you have also been given the concentration, that is 0.06 molar. So you can easily progress with this question. So let me just write down. What I am doing is I am placing the value absorbance log 4 equals to epsilon into C into L. Now you know what you do not know about epsilon, you know all the other values. So concentration has been given to you as 0.06. Epsilon we do not know. Concentration we know that it is 0.06. Length has been given to us as 8 centimeter. So now epsilon is equals to log 4 divided by 0.06 into 8. This is the final equation. Now if you solve this, you would get 1.254 mole inverse centimeter inverse. So you already know that epsilon has a unit of mole inverse centimeter inverse, so this would be the final value. This would be the answer. Just have to solve this. Okay, now see, in the first question we were asked the concentration. I showed you in the first question they have asked concentration. In the second question they have asked the epsilon values. You need to be clear with both the formulas of absorbance in order to do this. The third question, let us move on to this one. So this is a nice question. This would clear most of your doubts regarding this particular topic. So let us go through this. A solution containing, I'll just underline the important points. Okay, so a solution containing NAD plus and NADH had an optical density, that is absorbance, of 0.311 at 340 nanometer and 1.2 at 260 nanometer in a 1 centimeter cuvette. What does this mean? That the absorbance has been given to you of a solution that is comprising of NAD plus and NADH at different wavelengths, 340 nm and 260 nm. Now what is the question that is being asked to you? They are asking you the concentration of NAD plus. What is the concentration of NAD plus? And another feature of this question is they have given you that NAD plus and NADH absorption. They have given you that what is the absorbance, what is the molar absorptivity coefficients at different wavelengths. So looking at this particular table over here, you can see that NAD plus has a molar absorptivity coefficient at 260 nanometer, it is 18,000. At 340 nanometer it does not absorb anything, it is 0. For NADH, if you look closely, it is 15,000 at 260 nm, and At 340 nm it is 6220. So now you have to find out the concentration of NAD plus only. They are not asking you about NADH. They are asking you about NAD plus. Okay. Now what we can use, if you have carefully seen this table, you would understand that NAD plus is not absorbing. NAD plus is not absorbing anything at 340 nanometer. So we can make use of this concept, we can make use of this information, and we can start doing our question. Let us start with NADH, because NADH is absorbing at both the wavelengths 260 nanometer as well as 340 nanometer. So let us start using NADH. Okay. So first of all, let me just find out the concentration of NADH, because the concentration would remain the same in the solution, right? Whatever amount of NADH is present and whatever amount of NAD plus is present, it will remain the same. It would not get varied by the wavelengths that is being put into it, right? So first of all, let me just concentration finding concentration of NADH, finding concentration of NADH. So because you can see that at 340 nanometer over here, at 340 nanometer, only NADH is absorbing and NAD plus is not absorbing. So this is what I will make use of. So finding concentration of NADH from the absorbance at 340 nanometer. Okay, so let us do this. So you already know the formula. Again, absorbance is equals to epsilon into C into L. So over here you already know the absorbance. The total absorbance of the solution has been given to you, and that would be solely because of NADH. At 340 nm, the absorbance of the solution would be solely because of NADH and not because of NAD plus, because it is not absorbing only. So with this concept in mind, let us start. So the absorbance that has been given to you is equal to 0.311. This was the absorbance, and epsilon, you know, 6220, it is the epsilon value 6220 into concentration we want to find out, and length also we have been given, that is equals to 1 centimeter. So if you solve this, you would be getting a concentration of NADH equal to 5 into 10 to the power minus 5 molar. So this would be the concentration of NADH, right? This would be the concentration of NADH. 5 into 10 to the power minus 5 molar would be the concentration of NADH. Fine. Now, if I know the concentration of NADH, this concentration would remain constant even if I am checking it out at 260 nanometer or 340 nanometer. So let us just use this concentration value and find out the absorbance at 260 nanometer. Okay, so let us find out the absorbance because of NADH. So absorbance due to NADH at 260 nanometer. So now at 260 nanometer, the epsilon would get changed. It would be 15,000 over here, and everything else, the concentration, the length, all would be same. So let me just use the formula. A is equals to epsilon into C into L again. Okay, now what would be the absorbance? Let us calculate. Epsilon would be 15,000 into concentration, we have calculated 5 into 10 to the power minus 5. Length we also know, that is 1 centimeter. So if you calculate this, it will come somewhere around 0.75. This is the absorbance, right? So this is what we wanted. Okay, so we have got the absorbance because of NaDH. So this is the absorbance due to NaDH. Now we already know that total absorbance because of NaDH and NAD plus, isn't it? You already know it, so it is written over here. 1.2 was the total absorbance at that wavelength, and that total absorbance was because of NaDH and NAD plus, isn't it? So if I want to find out the absorbance because of NAD plus, how can we calculate it? So absorbance due to NAD plus, it would be total minus absorbance because of NADH. So we know that total absorbance was 1.20, and you subtract the absorbance that you just have got, that is 0.75. So it would be 0.45. This is the absorbance because of NAD plus. Now again using the same formula, A is equals to epsilon into C into L. If you are using the same formula, now you are aware about the absorbance, that would be equal to 0.45. This would be equal to extinction coefficient that has been given to you, isn't it? That is equal to 18,000, because NAD plus has a extinction coefficient of 18,000. So 18 into concentration, we do not know, this is being asked from us. Concentration into length is 1 centimeter. Now if you calculate concentration, this would be equal to 2.5 into 10 to the power minus 5 molar. This is the answer. This was a very nice question, conceptual question, that I believe all of you would have understood. So they were asking us the concentration of NAD plus. So we knew the total absorbance, we subtracted the absorbance because of NADH, we got the absorbance because of NAD plus, and then we used this data in order to calculate this. So this was the information about this particular question. Coming to the last question. Okay, so a protein has one tryptophan and one tyrosine in its sequence. Okay, so a protein has one tryptophan and one tyrosine in its sequence. Let me just underline the important thing: tryptophan and tyrosine, and these are one each, one tryptophan and one tyrosine in its sequence. Assume molar extinction coefficient at 280 nanometer of tryptophan and tyrosine. So molar extinction coefficient has also been given to you. Remember, the unit of molar extinction coefficient was mole inverse centimeter inverse. Okay, so 3000 and 1500. Now respectively, what would be the molar concentration of that protein if its absorption at 280 nanometer is 0.90 in a 1 centimeter cuvette? So this is a straightforward question. They have given you the molar absorptivity coefficient because and they have also given you the centimeter, they have given you the absorbance. One important thing you should remember, this requires a little bit of biochemistry. Now let us say that this is a protein sequence that I'm looking at. Now over here, let us say we have a tryptophan, over here we have a tyrosine. Okay, a tryptophan and a tyrosine, one each tryptophan. This is the tyrosine. Okay, now you should be knowing that both of these, tryptophan and tyrosine, are aromatic amino acids. Now they would definitely show some kind of an absorbance. This you should be knowing. Okay, so if they are present, and you should also have a, a, a careful eye towards what is the number of these sequences. So one each they have been given. So let us start doing this. If you understand this, then there is no problem in this question. So epsilon for tryptophan has been given as 3000 m-1 cm-1, and epsilon for tyrosine has also been given to you, and this is 1500 m-1 cm-1. Now, because of these two, as I said, that these two would be showing some kind of absorbance because of their aromatic nature. Now, since these two would only be absorbing, now if I want to calculate the total molar absorptivity coefficient, how would you calculate it? I can just multiply the number of residues of tyrosine with its molar absorptivity coefficient and number of residues of tryptophan with its molar absorptivity coefficient. So this needs to be done. So let us first of all find out the total extinction coefficient or total epsilon. Now this total epsilon would be because of tryptophan and also because of tyrosine. So how would you calculate this? This can be easily done. Okay, so number of tryptophan into epsilon of tryptophan plus number of tyrosine plus epsilon of tyrosine. So this needs to be done. Okay, if you do this, then this would be done. So let us start with this. So the number of residues of tryptophan is 1 into molar absorptivity coefficient of tryptophan is 3000. Okay, so 3000 plus 1 into 1500, because number of tyrosine is 1, tyrosine this molar absorptivity coefficient is 1500. So if you calculate this, this would be equal to 4500 m minus 1 centimeter minus 1. Now you have the total molar absorptivity coefficient. You just need to use the Beer Lambert law, and that would be A is equals to epsilon into C into L. You are knowing the epsilon value. You just have to calculate the concentration. You also know the absorbance. The absorbance was given to you as 0.90 in the question. I had underlined that this is the value. So absorbance is equals to 0.90. Concentration we do not know. Epsilon we have calculated 4500 m minus 1 cm minus 1. And finally we also know the length, that is equals to 1. Just put in these values in the formula that has been given. So absorbance is equals to, we just use this formula, and if I want to calculate the concentration, so A divided by epsilon into L would be equal to concentration. So this would be 0.90 divided by epsilon would be 4500 into length would be 1 centimeter. If you calculate this, you would be getting 0.2 into 10 to the power minus 3 molar. So this is the concentration. I believe you would have understood these questions, and because of this questions, the Beer Lambert law would be clear in your mind. Just remember these formulas. These questions are fairly important with respect to GATE BT, GAT B and CSIR examinations. So I would request you to look at these. And one more important announcement, the GAT B lectures are going on. The GAT B course has started from 20th. So this course is also beneficial for students who are preparing for GATE BT. If you want to start early, you can join us, and this course is really beneficial for all the GATE, GAT B and GATE BT aspirants. You can directly message me on 8299134528. This number is also mentioned over here, or you can directly comment it on the comment box of this video. Thank you so much and have a good day.